Have you ever stopped to think about how a body, well, how it builds itself? Not just what it's made of, the proteins and cells, but how does it know what shape to be? We're about to dive into an idea that is so mind-bending, it might just change how you see life, memory, and maybe even time itself.
It all kicks off with this little guy right here. This is a planarian flatworm. And what's cool about them is if you cut one in half, each piece just regrows into a brand new, perfect worm. But look at this one. This one has two heads. Now here is the absolutely wild part. Every single time you cut this worm, the pieces regrow into more two-headed worms. But its DNA, its genetics are totally 100% normal. So, what on earth is going on here?
And that really brings us to the central mystery we're tackling today. We're always taught that DNA is the blueprint for life, right? But what if it's not? What if DNA is just the parts list, the hardware, and the actual assembly instructions, the blueprint itself, is stored somewhere else entirely?
To start figuring this out, we need to look for what you might call the ghost in the machine. We're talking about that bizarre, goal-oriented intelligence that we see all over the place in biology, even in systems that have no brain to speak of.
This is where the work of biologist Michael Levin comes in, and he asks these fantastic questions, like how does a salamander know when its new leg is the right size and it should just stop growing? Or think about your own hand. How did your body know to stop making fingers when it got to 5? The answer, he says, is that cells form this incredible collective intelligence. They work together to solve problems, not just in our 3D world, but in what he calls anatomical space, the space of all possible body shapes.
Okay, so how do they pull it off? How does this collective mind actually work? Well, this leads us to our first huge reveal. It's all electric.
And this is where the whole thing just clicks into place. I want you to think about it like this. DNA isn't the software, it's the hardware. It gives every cell the basic parts it needs to function. But the software, the actual program that tells the hardware what to build, is bioelectricity. It's a physiological program that runs on top of the genetic hardware.
And this whole system has a name, a bioelectric network. Basically, cells are constantly talking to each other using electrical signals, passing information back and forth through these tiny channels called gap junctions. Levin calls this constant chatter a cognitive glue. It's what binds all these individual cells into one big, cohesive system that has a shared goal, a target shape it's trying to build.
And this is exactly how we get that two-headed worm. It's brilliant. Researchers started with a normal worm, which has a bioelectric pattern that basically screams, build one head. Then, they briefly messed with the communication between the cells, essentially rewriting that pattern. They created a new, stable memory that says build two heads. The key thing to get here is that they didn't touch the hardware. The DNA was unchanged. They just hacked the memory. And now that worm, and any piece you cut from it, follows that new electric blueprint forever.
Now let's zoom out a bit, because this idea of goal-oriented behavior isn't just some weird quirk of biology. It might actually be a fundamental property of how systems work, all the way down at the level of physics.
In physics, they have a name for this. It's called an attractor. It's just a state that a system will naturally end up in. The simplest way to picture it is a marble rolling around in a bowl. It doesn't matter where you let it go, it's always going to end up at that lowest point in the very center. That low point, that's the attractor. For our worm, the one-head shape is its natural attractor state.
But this is where things get really, really weird. Some physicists are now arguing that causation isn't just a push from the past into the future. It's possible that a system is also being pulled by its future goal, by its attractor state. The only reason we experience time as a one-way street is because that's the only direction we can form memories. But the system itself? It might be computing things using information from both the past and the future.
Okay, so biological and physical systems can be pulled toward a future goal. But what if that same logic applies to something way more complex, like our own minds? To even begin to understand that, we have to turn the lens inward and explore what's called the logic of contradiction.
We're constantly taught to think in binaries. Something is either good or it's bad, right or wrong, true or false. But real, complex systems, like our own consciousness, or even our societies, they just don't work that way. They are perfectly happy holding multiple, even contradictory truth, all at the same time.
Let's use the debate over cannabis to make this concrete. At the individual level, you might feel the deep contradiction, like, this helps my anxiety, but it also really hurts my focus. At a bigger policy level, you see this tension between giving people access and managing the risks. A more developed system, at what we're calling level 6, learns to just tolerate these contradictions. It asks better questions, like, okay, under what conditions does it help, and under what conditions does it harm? And then at the highest level, level 9, the system becomes this kind of meta-witness, asking an even bigger question. What is the actual goal of regulating this in the first place?
We can actually simplify this whole way of thinking into a little framework, 369. The number 3 represents the thesis. This is your starting point, your initial position. So, for example, the simple statement, "This helps me."
6 represents tension. This is that interference zone, the place where a contradiction is held without just collapsing. It's the moment where you can hold both truths. This helps me and it harms me. The system is holding both at the same time.
And 9 represents synthesis. This is that higher-level perspective, that meta-witness we talked about. It can look down at the tension of 6 and make a conscious choice. It doesn't get rid of the contradiction, but it manages it by picking a new, bigger goal that moves the whole system forward.
So, what is the point of all this, really? The point is that if we start using this systems thinking framework, we can begin to understand and maybe even rewrite the code that runs our own societies.
Just look at the debate over a wealth tax. You've got two completely opposite, deeply felt views. One person's perspective is rooted in history, seeing it as a tool that created a middle class. Someone else sees it as a direct punishment for being successful. These aren't just arguments. These are the goals of two competing systems, each trying to pull society toward a very different future, a different attractor.
And this is a perfect real-world example of that feedback loop in action. You start with the thesis. A media platform is broadcasting toxic stuff. Then comes the antithesis. An activist group organizes and starts contacting the show's advertisers. This creates tension, right? The media outlets attack the campaign, but the pressure works. The advertisers get nervous and pull their money, and that leads to a synthesis. The platform's financial model collapses and it's forced to change. That is a system being pushed toward a new state.
So, the most important thing to take away from all this is that when we look at our polarized world, we're not just seeing people arguing. We're seeing complex, dynamic systems in action. They've got feedback loops, they have competing goals, and they are all being pulled constantly towards different possible futures.
Which of course leaves us with one last massive question. From the memory of a single cell to the logic of our global conflicts, if our world really is governed by goals just as much as it's pushed by causes, then what future, what ultimate attractor state are we, all of us, being pulled toward?